Welcome back to Data Science at Home podcast. I'm Francesco, your host for the next 20 minutes or so. And today we are tackling something that's been kind of bugging me for a while, something that I call the AI shortcut trap. And of course, I will take some time to explain what I mean by this and what are the consequences of this because there are no very good news for us guys. Now the reason of this episode is just to anticipate and definitely show some of the fact that everyone suddenly became an AI expert these days, because there are very powerful tools, and of course, in my opinion, it seems like people are kind of forgetting the foundational science behind the tools they use, and that's a problem because, as I will try to explain, there can be very bad consequences. So let's get started. So, as I said, the AI shortcut trap is a thing. The way everyone suddenly became an AI expert without really knowing how artificial intelligence truly works. We're talking about what I call in this AI shortcut swindle of 2025, or in plain words, how drag and drop tools are, in fact, tricking people into thinking that they understand artificial intelligence. Now, I want you to picture something like this, which is quite common these days. Imagine it's Tuesday morning, you have barely had your first coffee, and you decide you're going to change the world with artificial intelligence. I mean, now this is happening every other day. So, if your plan is to spend months learning mathematics, algorithms, and statistics, congratulations, you're doing it the hard way or the old school way, which, by the way, is the only way that works. But of course, if your plan is to open up a no code platform like N8N or any other of these magic tools, connect a few colorful blocks, and call yourself a machine learning engineer, well, I'm regret to inform you that you're not alone. That's what most people do today. And hey, of course, no code tools are fun to use, even to build. I'm one of them. They're like Lego for grown-ups. You drag a block here, you drop a block there, and suddenly you've got something working, right? It feels good. It's kind of rewarding. It's like a game, right? But it's like those cooking shows where the onions are already chopped for you. You don't have to dirty your hands. Everything is crystal clear, except that you don't actually know how to cook, right? That's the problem. So this thing is worrying me because I believe that we are raising a whole wave of AI professionals who actually don't know the basics, right? It's like using Google Maps every day but never learning how to read a real map. Is there anybody still reading real maps out there? Maybe not, but in any case, GPS works until it doesn't, right? So what happens when, you are in that bad day, your phone is not working, out of battery, GPS not available, you're lost. I met someone very recently at a conference. This was one of these online conferences, who told me that they were building neural networks entirely with no code platforms. So I asked them if they could explain backpropagation, the key algorithm that actually makes neural networks, well, learn. And they looked at me like I was speaking another language. And that's the scary part. We are building systems that affect real lives, and too many people building them don't understand what's going on under the hood. And that's scary. I'll give you another example. These folks who win a gold medal in AI competitions, there has been many even in data science. There are platforms that do that. I don't want to make names. You know what I'm talking about. Now, it wasn't because they had the prettiest drag and drop workflow. And if you ask them, all those, masters who actually mastered that activity of winning one of those competitions, they actually very rarely, if never, used drag and drop workflows. It was because when their model broke at 2 a.m. a few days before the deadline, they knew how to fix it. They understood why the model was failing. They spotted problems in their data. They knew how to debug. That's exactly what separates a real practitioner from someone who just clicks blocks together, right? Now, Of course, math is hard. Statistics can be confusing. Calculus feels like torture sometimes. But that difficulty is actually important. It's what makes you capable of building solid systems instead of fragile ones. When you understand the mathematics behind artificial intelligence, you actually stop being just a tool user. You become someone who can shape new tools, new ideas, and of course, provide new solutions. Right now, a lot of people, at least the ones I'm dealing with, are learning the equivalent of cruise control, but not learning how to actually steer a car, right? Everything is going to be fine as long as you're on a highway with not so much traffic, but as you get to the city uh, or to a very high traffic area, you're screwed. Now, we're also living in what I call the era of cosmetic innovation. On the surface, everything looks shiny, slick interfaces, cool demos, flashy presentations. I think I've never experienced so many really, really good demos these days in my career. Like, usually demos were used to be shit. Today they look production ready since day one, right? But when you look closer, and a lot of these systems are built like a house of cards. They work until they don't. And when they fail, the problem is that nobody knows why, because the person who built it never actually understood it. It's like building a skyscraper with IKEA. It looks great in pictures. You find these amazing, interior designs on Instagram, but you probably wouldn't want to live during a earthquake. Now, in Europe, we love to talk about trustworthy AI and ethical AI, which are good things, of course, except that Europe is probably thinking only about these things, but that's a different story. All this stuff is good, but how can we make AI trustworthy if the people building it doesn't really understand it? It's like asking someone to be a doctor after reading, one of these portals like WebMD or stuff like that. Well, the computer says you're sick, but actually don't know what that means. Now, we need to be very honest here. Do we want a generation of people who can just operate AI tools, or do we want a generation of actual innovators in AI? So here's a crazy idea. What if we slow down? I know that in a field moving as fast as artificial intelligence today, that sounds impossible, but think about it. Instead of rushing to use the latest shiny model, what if we actually took the time to learn how it works? What if instead of just applying tools, we studied the mathematics behind and the theory behind them? Deep understanding, of course, takes a lot more time than just, downloading the latest model and fire up a tool. But without understanding, we're just drifting wherever the current takes us. Now, the biggest breakthrough in artificial intelligence didn't come from drag and drop workflows or cosmetic tweaks. They came from people who went deep into the fundamentals. For example, convolutional neural networks. They were new in 2010s, but researchers finally had the math, the compute, and the insight to scale them. And that led to ImageNet. And suddenly, computers could actually recognize objects in photos better than most humans. That was the breakthrough. Or transformers, for example. Attention mechanisms might sound abstract, but they completely changed natural language processing, as we know. So without attention, just for the record, you don't get GPT, you don't get ChatGPT, you don't get today's LLMs, pretty much all of them. So that one concept flipped the whole field. And the other elephant in the room, reinforcement learning. When DeepMind combined it with deep neural networks, they didn't just make a game playing bot, but they changed how we think about agents that learn by trial and error. And that's how AlphaGo happened. That's deep innovation. Now let's look at the other side. The improvements that sound cool but don't really matter. Like every year someone renames an optimizer and claims it's the next big thing, right? We had Atom, we have Super Atom plus plus Ultra, and it's in reality it's just Atom with a small tweak that doesn't move the needle. Or all those endless model zoo papers where someone takes RESTnet, adds 3 extra layers, changes the activation function, and boom, they say it's new state of the art. They measure the accuracy, it's a tiny bump of 0.x%, and which of course vanishes with real world data. Or even worse than this, the obsession with making models spits out emojis or whatever art people, whatever thing people call art, or yeah, AI art or something, or AI generated motivational quotes. Yeah, it's fun, but let's be honest, that's not innovation. It's what I call digital glitter, right? So, how do we avoid the great shortcut swindle? Or how do we get off the trap? Well, first, don't run away from math. Yeah, it's tough, but it's worth it. Second, start asking better questions. Not just how do I use this tool, but why does it work? Why this tool work? When does this tool fail? What assumptions does this tool have or it's making? Third, build something from scratch at least once. I've done that. Many people have done this. You have to do that too. It's slower. It takes time. It's a very time consuming process, but the experience is amazing because you will actually build something, first of all, and second, understand it truly because otherwise it wouldn't even compile. Uh, Even if it's worse than a pre-built binary, and believe me, it will, for obvious reasons, uh, you'll learn more from one failed homemade model than from 1,000 polished ones that you didn't understand. You just downloaded it and pushed the play button and good to go. So the future of AI doesn't belong to the people with the fanciest tools. It belongs to the people who really understand what's going on. Don't take me wrong, tools are great, but tools without understanding are just expensive ways to make mistakes. Innovation isn't about being first with the latest model, it's about seeing patterns, it's about understanding problems, and of course, creating solutions that actually last. So the next time you're tempted to drag and drop your way through AI, stop and ask, am I really solving something or am I just rearranging digital furniture? The choice is yours, and honestly, the future of AI depends on it. That's it for today's episode of Data Science at Home. Remember, the only thing worse than not knowing is thinking you know when you don't. Keep learning and read the docs. Bye.